Hey guys, welcome back. Welcome to the next set of video, which is the how to calculate float. So this is the second video for the network diagram section. So first of all, we computed the critical path. Once we compute the critical path, then we would be calculating the float. Float is also known as slack. So if in the exam they ask you about float or a slack, this means they're talking about the same thing. And before understanding the concept of float and a slack, let's first calculate an node. Let's first understand the concept. So this is an activity on node method. So this is a node A, which has a duration of, let's say, 4 days. Let me change the color first. So this corner, there are 4 corners. This corner is known as early start. This one is known as early finish. The bottom ones are known as late start and late finish. So the formula for float is LF minus EF. Similarly, or there are two formulas, you can say, or it is LS minus ES. So both of these would be same. So either you calculate LF minus EF or you calculate LS minus ES, it would be a same number, which was known as float or a slack. So this ES and EF, which is known as early start and early finish, they are calculated using forward pass. The LS and LF is calculated through backward pass. So first let's understand what is ES, EF. We would be following forward pass in this case, and then we would be going through LS and LF, which is backward pass. So early start and early finish. Early start is the earliest possible start date for an activity based on the expected duration. So duration is given to us and the earliest possible start date would be known as early start. Similarly, for early finish, it's the earliest possible date an activity could finish based on the expected duration. So duration is given to us and the activity, the earliest finish date would be the early finish. Early start and early finish are calculated by forward pass. So let's now understand what is a forward pass. So to begin a forward pass, always start from the left side of the diagram, of the network diagram. So this is start. If days are units of time being used, then an activity starts at the beginning of the day and activity finishes at the end of the day. So earliest start would be, in this case, the activity which can start on the beginning of the day, which is 1. It would be starting on the first day, the beginning of the day 1. An early finish. So to calculate the early finish, we have a formula. Early finish is early start plus the duration minus 1. So in this case, early start is 1, duration is 15 minus 1. So it's 1 plus 15 minus 1 is 15. So early finish would be 15. So it would start on day 1, the beginning of day 1, and it would complete on the end of day 15. So when we go from develop requirements to design UI, so if develop requirement finishes at the end of day 15, then how soon can design user interface start? So it would, so this is the 15 day, on the end of the day 15, this particular requirement, develop requirement task was complete. Design UI would begin on the next day, the beginning of next day, which is 16. And again, to calculate the early finish of design UI task, it would be early start plus duration minus 1. So in this case, it would be early start is 16 in this case. Duration is 20. So 20 plus 16 minus 1 is 35. So it would be finished on end of day 35. So this is a forward pass. So if you see here, so I have actually computed these two. So it was 1 15, 16, 35. ES, this would start on 36th day. And if we calculate 36 plus 20 minus 1, and similarly if we go through, so let's we will be doing a complete pass of all these paths which we have, which will help us to give us the duration 69. So if you see here 16 plus 16, 35, we started on the next day, which was 36. Then it was 36 plus 20 minus 1 is 55. Then again we began with 56. Then we added duration 56 plus 4 minus 1 is 59. And from here 59, we start on 60th day. 60 plus 10 is 70, minus 1 is 69. So similarly, if you see here, but remember one thing, this would help us to do a left to right, and it would give us the early start and early finish for each of these activities, each of the tasks. But if you see here in this particular case, create data tables. Let me change the color here. So when I'm talking about this particular task, create data tables. So if you see here, from here 24 is coming, that it would begin on day 24, and from here day 30th is coming. So but we selected day 30th. So whenever we do a forward pass, always the larger number goes to the next. Larger number goes to next node. So in this case 24 was coming, and from this 30th was coming, so we took 30th. Similarly, so it's, and if you see here, from here 43 was coming, from here 59 was coming, so next day would be 60th, and from here 44. So if you see here 60, this would be 44, and from here 52. So out of these, the larger was 60, so 60 went here. So this would help us to calculate the early start and early finish for all the nodes. Now let's go back. Now let's go to late start and late finish. So what is a late finish? The latest possible date and activity could finish without delaying the late start of subsequent activity or the project finish date. So it's a latest possible date and activity could finish. We would just want to make sure that the start of the late start of the next activity is not delayed, and also the project finish date is not delayed. Similarly, late start is the latest possible start date for an activity based on its late finish and expected duration. The traditional way to calculate these is to perform a backward pass. So in this case, we would be working through the backward path. So for early start and early finish, we went through the forward pass, but for late start and late finish, we'll be doing a backward pass. So now we are moving backwards. To perform a backward pass, begin on the right side of the diagram. So now we are working through the right side. For forward pass, it was from left side, but for backward pass, it's from the right side. So it is 69 here. So working right to left based on the expected duration, what is the latest possible start and finish date for an activity? So from finish, it was coming 69. So let's first now calculate what is the late start and late finish. So this 69 would go here. If the project finishes at the end of day 69, then how late can a test finish? So if it's finishing on 69, how late it can finish? So it can finish on 69 only. Similarly, what would be the late start? If test can finish as late as the end of day 69 with 10 days of duration. So how late can a test start? It would be 10. So again, it's the same. So how did we calculated it? So it's LF minus the duration of that activity and plus 1. So when we were going from, when we were calculating the EF, so it would be from that it was early start plus duration minus 1. But in this case, it's late finish minus duration plus 1. So in this case, if we calculate, late finish is 69 minus duration is given to us 10 plus 1. So it would be 70 minus 10, which is 60. So now we will calculate the late start and late finish for all. So if we see 69 is coming here, 60 is coming. So for all the late finishes, it's the previous day which is coming. So 59 came, 59 went through all these three. So if you see here, 60, we finished on 60th date. A day before went, so it's 59. Then we calculated 59 minus 10 plus 1 will give us 50. A day before will start, which is 49. So this is how we will calculate. But remember, for backward pass, a number which is lower will go. For forward pass, a number which was more larger was supposed to go. But in this case, the number which is more would go. So let's see here. So if we see here, this is 46. So this 45 came and 45 came in this case. Similarly, if we talk about here, so from here 38 was going, and from here 32 was going, from here 16 was going, and from here 24 was going. So in this case, if you remember backward pass, the lesser number will go. Lesser number will go back. So out of 16, 38, 32, 24, 16 is the lowest one. A day before we will start, which is 15 in this case. So now we need to make sure that what is the critical path. So if you see the critical path, the early start and the late start for each activity on critical path is same. So if you see early start and the late start is same. Similarly, the early finish and the late finish is also the same. So what is the definition of float or a slack? It's the amount of time a particular activity may be delayed without affecting the change in the critical path. After you have performed a backward pass, you can easily calculate the float for each activity. Simply, if you remember, the formula for critical path was late finish minus early finish, and similarly, or late start minus early start. So in the critical path, it is 0. If you see here, 69 minus 69, 0. 60 minus 60, 0. 59 minus 59, 0. So similarly, if you see all the nodes, it would be 0. So now we have to calculate the float for each activity. It's pretty simple, just subtract. So if you see here, it's 59 and this one is 43. So 59 minus 43. So if we let's start from left to right. So on the critical path, it would be 0. So if we say here 38 minus 16, it would be 22. Similarly, or if we do 45 minus 23, then also it would be 22. If we do 46 minus 30, it would be 16. Similarly, 50 minus 34 would be 16. Again, 32 minus 16 would be 16. 24 minus 16 would be 8. 34 minus 26, 8. 8, 8. So for the critical path, it is 0. And for rest of the tasks, it is given to us. We have calculated it. So in the exam, they may give you a particular node and ask what is the float or a slack of this particular activity. If it is on critical path, no need to calculate early start, early finish, late start, late finish. It is automatically 0. But if it is not given, this is how we can actually calculate it. So if they ask you what is C's float, we know that C, A, B, C, it's on 21. So we can actually calculate it by finding the early start, early finish, and late start and late finish. So this is an example. It's an way to represent. Let's calculate. We have given early start is 15. This is early start. This is early finish. This is late start and this is late finish. So we need to find what is the duration of activity K. So how we can calculate K? If you remember, we have a formula which is early start plus the duration minus 1 is equal to early finish. So this is the formula. We know what is early start. It is given to us 15 plus duration is K minus 1. Early finish is also given to us, which is 28. So if we calculate the value of K, let's take these values into other side. So it's 28. This one went to this side. Because it was negative, it became positive. This 15 also went to the other side of the equation. It was plus 15, so we did minus 15. So it's 28 plus 1 minus 15. It's 29 minus 15. So it's 14. Now what is the float? So if you remember, the formula for float is LF minus EF, or it is LS minus ES. We don't know what is LS, we have not calculated it yet. So let's do it from this way. It would be 34 minus 28, which is 6. Now let's calculate what is the late start. So again, we know the float is 6 in this case. And we know what is the formula for float. It's LS minus early start. So 6 equal to late start, we don't know. Early start is given to us 15. So LS is 6. Just take it 15 to the other side. Plus 15 is equal to 21. So this is how we actually calculate it. You may find questions in the exam, something similar to these, and this is how we would calculate it. So next concept is about free float. Free float is the amount of time a scheduling activity may be delayed without impacting the early start date of any subsequent scheduling activity. So free float is, we just want to make sure that we are not impacting the early start date of the next activity. So this is how we would calculate. It's actually dependent upon three things: that the free float will always be less than or equal to the float. Float focuses on the finish and the critical path, but free float looks at the subsequent activities and it is free from critical path. Always remember, free float is free of critical path. So anything which is, the float is actually working on the critical path, but free float is free from the critical path. So let's calculate what is the free float for an activity E in this case. So let's first perform the forward pass. So we started on day 1, again 9, we started on 10, 19, 20, 23. So from here we are coming 23. Let's do it for the second path. It gives us 23. Third path gave us 26. Fourth, let's see what is the fourth path giving us. Okay, so now if you see here, we are on the forward pass. From here 15 came and from here 27 came. When we do the forward pass, the number which is larger would go, so we would start on next day or 27, which is 28. Similarly 28, again 28 plus 11 minus 1, it's 38. So from here 38 would go now, so which is the next day, sorry, 38. So we computed the forward pass, and from, if we need to calculate the free float for an activity E, and if you remember, the free float is dependent upon the subsequent activity. So in this case, it's C and H. However, if you remember the second set of video which it said, let's read. Free float focuses on the finishes, but free float looks at the subsequent activity. So we need to make sure what are the subsequent activities. And again, it's also free from the critical path. So if you see here, the subsequent activities is C and H, and it is free from the critical path. So this H is on the critical path. So let's remove it, and we are only left with E and C. So only activity which is in this case is C and not H, because it's free from that. So now, how long can activity E be delayed before it impacts the early start of the activity C? So this is the definition of free float. Again, let me read it again. So how long can activity E be delayed before it impacts the early start for activity C? Is it 4, 20 minus 15 plus 1? Sorry, 20 minus 15 minus 1 in this case. So always remember free float, how this is calculated. So first of all, we need to find out on which particular activity it is focusing. Then it would be early start of next activity minus early finish of the activity being asked and again subtracting minus 1. So in this case it would be 20 minus 15 minus 1, which is 4. So this is the network diagram discussion, and this is the last section of this video. I hope I've explained you the concept of network diagram. And remember guys, you need to practice lots and lots of questions from network diagram. You may find approximately 5 to 7 questions on network diagram questions. So we have an activity M. Let's draw it. This is an activity M. Early start, this is early start, this is given to us 1. Early finish is given to us 187. Late start is given to us, which is 3. So what is the float and what is LF? So we need to find out this, and we need to find out what is the float. So how the float is calculated? What is the formula for float? Float is LF minus EF, or it is LS minus ES. So in this case, LS is given to us 3 and ES is given to us 1. So in this case, it would be 3 minus 1, 2. So float is 2. What is LF? Again, LF minus ES is equal to LS minus ES. Both of them are giving the same thing to us. So LF, we don't know what is LF. EF is given to us 187. LS minus ES, we have already calculated, which is 2. So LF is 2 plus 187 is equal to 189. So this marks the completion of the second video of network diagram. So next we would be going through the revision section. You can go and revise what all processes we did in time management knowledge area. And finally, we would be moving to the next knowledge area, which is cost.